We should be live. Hello, everybody. Hello. We are just coming on now. I think we're live. Yep, good. Hi, everyone. Welcome to this combo Rust Manchester Lambda Lounge stream. Thanks to everybody for turning up. I think we've got, I don't know how many viewers we've got. 15 already. That's good. Yeah, so hello, everybody. We've not got a whole lot of intro to do. We've got Alex. Wave, Alex. And we've also got Andy and Jamie from Rust Manchester. So for the sake of everyone from the two meetups, I am both in Rust Manchester and in Lambda Lounge, and we're sharing this. And then we've got the other guys. Yeah, I don't think there's any other announcements. At the end of this, we'll throw a Zoom link out if anyone wants to come on and do a brief social afterwards. We'll chuck a Zoom link out. We'll also chuck the Discord link out for the Lambda Lounge Discord if anyone wants to join that. But otherwise, I think we should probably get going. So, yeah. Okay. Hang on a minute. Bring the slides back. Alex, are you good?
Yeah, I think I'm good. Right. Okay.
I will leave you to it and we'll pop back on if we need to.
All right. So this talk is going to be about smart contracts in Rust, with the disclaimer that is implied by this title that I'm not a native Rust developer, or do I consider myself particularly good at it. I have background in functional programming, functional TypeScript, tiny bit of Haskell, that I've never been paid for it, tragically, and many years of Clojure, which is of course a dynamically typed functional Lisp, so pretty different to Rust. But I'm sure I'm not the only one who is watching CLJ RS with a great deal of interest in my spare time. So smart contracts, obviously part of the broader crypto ecosystem, and I like to think that I have a relatively thick skin compared to a space that generally has, I think, a reputation for thin-skinned people. So there'll be a fair bit of self-deprecating stuff in this talk, besides actual facts and hopefully even a couple of funny memes. So a tiny bit of context first. People talk about Web3 or the interchain. What is the interchain? Pretty much that. What else is it? It's NFTs, and thus, by definition, a lot of other people getting upset about NFTs, and just any number of things that are kind of holy wars because the space is still so new and evolving that there's just fires everywhere, wherever you look, all the time. But I think one thing that people that I know who are curious about what crypto is actually like on a day-to-day basis are surprised by is how insane it is when you're actually inside it. So at the moment, there's obviously a really interesting thing, I think, is from a product development perspective, when a lot of what we do as engineers is we take things from a custom one-off thing, like a new idea, and we commodify it. And in doing so, sort of bring it to a wider market, but that you also make something, essentially worthless. And what we've seen, particularly over the last year, is like the idea of a cryptocurrency being essentially worthless because it's so easy to spin one up, and that's kind of like shit coins and shit chains. And when you launch smart contracts, it means that you can develop these kind of tokens and protocols so quickly that you can see, like, over the course of a few days, something go from valuable to being completely worthless, which is kind of fascinating from an economic perspective. And also that everything is open source by necessity, because that's the only way people can audit things. So it also means that everybody is ripping off everybody's code, and the people who have actually done the most effort are usually not the ones necessarily that profit. The meme chain is always the biggest IQ play, at least if you want to make money. And not to rip on just random chains in the eco that I work in, but this is an actual thing from an actual chain where they say this about themselves. But they made millions of dollars. So mastering shitcoins really is the biggest brain play you can make. In spite of that, well, actually, yeah. So also everything is done with no sleep as well. So there's like 100 things happening all the time. Everything is like 100 miles an hour, and so half the time you're sort of like this, trying to remember server ops or like get your code to work or whatever. There's a lot of juggling, but yeah, we're not working with money according to HMRC. So obviously it's all okay. And you should get involved because Rust is cool. And so that was a very weird bait and switch where I just ragged on what I do for most of my time for about 3 or 4 minutes and then went, hey, Rust is cool and therefore everything is okay. And yeah, that's, I guess, why we're doing this talk, right? So joking aside, one of the cool things that I've already alluded to, right, is that you can see the commodification of things that are brand new happening in front of your eyes, which means by definition, there are a lot of things that are, for some definition of new happening in the space. Some of that might even be, for some definition of cool, which means that I am going to make the bold claim that there is a lot of cool stuff up for grabs. So even in NFTs, right, which everybody thinks they know and definitely has an opinion on, I think most people think of this little Cheem Doge over here like some fucking Bored Ape clones bullshit. But actually, you know, there's a whole lot of cool stuff you can do, right? Because, well, I mean, so any primitive that requires uniqueness could be an NFT, right? And in addition, so a lot of the criticisms you see of stuff like maybe on Ethereum is that you find that the metadata or the things that actually make the NFT are actually held off chain, right? That's a function primarily of gas. So gas, which is the transaction medium for Ethereum, is very expensive. So it would cost a lot of money to store that data on chain. That's not true of every L2, which is like sort of a derivative chain of Ethereum, or indeed other blockchains that are maybe where Bitcoin was generation 1, let's say Ethereum was generation 2, like a sort of Gen 3 chain. High gas is not a given. So you can actually store a lot of this stuff on chain, and that makes for very interesting new primitives that are available to you as a programmer. So we should probably talk about some more smart contracts, or I should talk about them at least. Hopefully this isn't this is a very obvious statement. So, but what is a smart contract? Smart contract is just blockchain hosted code. In Cosmos, which is the ecosystem in which I work, CosmWasm is the tool chain for this, standing for, as I imagine you've already worked out, Cosmos and Wasm. And the tool chain for that is CosmWasm VM, which is the VM, CosmWasm standard, which is the library, XWasm, which is the module in the Go SDK that will run the code. And we're not going to talk about Go in this, but yes, it is obviously, so the Rust that you write in these smart contracts gets compiled to WebAssembly, but ultimately the chain substrate is Go. And then WasmD is the example implementation of a chain running CosmWasm. The anatomy of a contract is pretty simple. There's a execute hook, query hook, and a few others that we're going to talk about. So broadly speaking, the contracts themselves follow an actor model. They can call each other. They can do some quite complicated interaction behavior, but it would to go through it all would probably be a little bit much for what this is sort of supposed to be quite a short and sweet talk. So yeah, that's there are a bunch of good blog posts and whatnot, as well as documentation on the CosmWasm doc site that can take you through the anatomy of how some of those more complicated interactions can happen if you're curious. But the ones we're going to focus on here are execute and query. So yeah, execute allows you to do writes, essentially. Queries allow you to do reads. Like on Ethereum, if you've ever worked with Solidity, the queries are free. And obviously executes cost you gas. So they cost the gas token in order to actually execute. And then underneath all of that, you have access to state, which is the representation of the key value store underneath, which is, you know, the bit that you're writing to the chain. So, you know, when all of the, you know, the party hats and everything are cleaned away, and you know, you're left looking at smart contracts in the cold light of morning, it's basically just a normal app, you know, server-side application that you would run in any other scenario, where the chain is your database. You have the state part of your smart contract is your database interaction library, and then the rest of it is pretty much as you'd expect if you've ever worked in a NoSQL kind of environment, with some caveats. Like the code is a little bit more inherently complicated to update, and some of the way in which you query stuff is, it's not going to be either as performant as, let's say, Apache Cassandra or anything like that. And some of the primitives you might be used to expecting in those environments might not exist yet. Though it is worth saying that CosmWasm is pretty feature complete already, even at version 1, compared to some of the things that have been available in the past. So execute and query at a code level are these big enums that can be used to generate a JSON schema with cargo. That JSON schema then is used to validate sort of inputs coming over the wire. And yeah, it means that for a newcomer, if there's people who are much more familiar with Rust here than I am, I found that the extension semantics of enums are perhaps not ideal. I mean, especially as somebody coming from Lisp. But it does mean that actually being able to sort of share people like what they should expect from your contracts is very easy once you have generated the JSON schemas from your enums. And I'm just going to stand Rust a little bit here. Like I say, I'm not particularly good at it, but I find the safety guarantees of the language plus the compiler are just a continual joy to work with. Having that kind of almost Haskell level of like decent compiler and safety guarantees, and the additional factor that unlike all the problems you can get with Solidity, this wasn't just homebrewed essentially to do one thing. It's a general purpose programming language, and your editor will tell you when you've done naughty things. So also, if you generate any CosmWasm contract, you get some Clippy settings out the box, although obviously Clippy's not hard to set up. But again, it's that back to having like one kind of true way of doing things. Personally, I find is really useful because, reminder, don't really know what I'm doing. And we're working with money. Let's just say it, we're working with money. So I was going to do a higher stakes live demo. I'm going to chicken out and do a slightly lower stakes one, principally because I am in the middle of nowhere in Wales, and I thought I was going to be in the city today with access to sweet fibre broadband, but I don't have that. So I'm instead going to try generating a CosmWasm contract template and then show some of the main hooks in Rust code, and we'll see if this actually works. It might not. So bear with me a second while I stop screen sharing and try and share my terminal. Where is the option to share my screen? Okay. I'm going to boldly assume that my screen is now showing my terminal. So yeah, okay. I think it is showing my terminal. So
it is. Don't worry. I have to come in for you to hear me, which is annoying. But yeah, it is.
Cool. Okay. So we've just run a cargo template. It's from Wasm, which is the as the name suggests, again, it's the sort of interchain organization. It is a DAO. We're not going to get into what that is now if you don't know what that is straight off the bat. That helps to manage essentially developer relations for CosmWasm. Yeah, there's a bunch of tooling, a bunch of documentation, also a bunch of like, bounties and whatnot for doing better documentation and stuff. If that's the thing if you are interested in writing smart contracts and you get into writing smart contracts and then you feel the need to contribute back, then there are bounties and all sorts of things available for you if you're interested in doing so. So we've created a project called Lambda Lounge. You can see it's just generated a bunch of stuff, including some useful hooks. So that as soon as you push it to GitHub, Clippy will tell you you're an idiot, which is magic because usually Clippy is right for me, in my case anyway. And I'm struggling to spell Lambda Lounge. Oh yeah, I can just tab complete. And it's probably going to throw me to the wrong window now. James, can you see my editor?
Yes, we can. It will need to be bigger. Yeah, that's good.
And that's massive. That would do.
That is too big, definitely.
That's too big. That's now too big. Okay.
That might be good. That looks like the right kind of size.
I'm hoping this is going to be the right size. Some anatomy here. You got a lib file that should be pretty straightforward. An error file which will pull in some basically some standard errors from the underlying CosmWasm standard library here. You'll find that most errors you're ever going to need to use will actually already be defined for you somewhere, and you're going to be using some variant of something like unauthorized a lot, because the kind of unauthorized user error is your main error case, I find personally. Anyway, and then the main interesting things, right? So we talked about messages, so we talked about query, and why is my editor not wrapping? Let's wrap. Let's work out how to wrap on the fly. Word wrap. Hey, there we go. Okay, cool. So we said that there's an execute message and query message. This is when you instantiate a new contract project, it gives you this really simple project, which is just a counter, right? It's just you can increment it, you can reset it, and you can get the count, right? So our execute message here, which is writing state, has only two hooks: increment, reset. Reset takes resets to a number by the look of it, and then we have query message, which is going to get you count, and it's going to be JSON encoded. It's because somebody's written a helpful string here. It's also worth saying that I mean, some of you might know this because you might work with the JSON encoding library that we're using here. But when you generate the JSON schema, if you put // comments above the thing, it will include that as the description string for the JSON schema. So that's pretty useful as well for telling your developer users what they're going to get back. So yeah, execute message, that's what you're writing. Query message, that's your reading. And then in state here, we have a very simple piece of state. So this is so interesting thing here. We've got item new state. This key here is essentially like the key inside the key. There's already a key value store, which is the chain itself, and then there's an additional key inside the smart contracts place on the chain, effectively, which has to be unique, and that's what this state thing is here. An item is just a single bucket of data, so there are much more complicated data structures available to you. There's maps, multi maps, index maps, and multi-index maps, and snapshot maps, and a few others that I've probably forgotten. You can also, for example, put tuples as a key in a key value structure, and then use one part of the tuple as a prefix to look up that thing. So there's actually like a surprising amount of flexibility with sort of like native types in sort of creating data structures. Quite a common pattern, for example, as well, to like, I don't know, make a set would be to do something like okay, we're right, this might actually not be correct code, but it would be something like this. Map. So let's say, okay, so it doesn't really matter what you have a type of. So in this case, we'll just go like address, because it probably is going to be an address. So if I wanted a set of addresses, let's say like wallet addresses, I could do something like this. And then it would be, it's like map. Why would I call it set? I don't know. I wouldn't. It's a really bad example. But that's how you would do like a set. So maybe that's really obvious to people. I don't know. But so it's a surprisingly flexible surprisingly flexible data storage model, given how sort of relatively basic some of the stuff in Ethereum is, or was. At least it's getting better. So that's kind of cool. And that's all contained in a CosmWasm library called Storage Plus, which, again, you can go look in the documentation of it. It has loads of actually pretty good documentation contained in its GitHub README and repo for all of the different access patterns. So this one here, this is just a single item. It contains a state. That's this thing here, the count and owner. And then we get to see that in action by, oh God, it's probably going to blow up a bit because I hit save. So it probably compiled it. Okay, so this is a bit overwhelming because I've blown it up so big. Hopefully it's not quite as overwhelming to everybody else. But so every contract has a life cycle. The first thing you do is you write it, then you compile it. You'll compile an optimized version of it, and CosmWasm give you a Docker container for compiling optimized contracts. Then you store it on chain, and then anybody can instantiate that code. So this function here is like a really core part of the cycle. So instantiation is where you create as the name suggests, create an instance of the running code that can then be interacted with. So most entry points look really, really similar. There's 3 main entry points you have to care about: instantiation, execution, and querying. And you notice that the things that are passed along, a message and deps, which is the storage engine, deps, just think storage, are pretty similar. So, execute, you've got deps, environment, info, kind of, it's the message info, which includes the sender and funds, so like gas and whatnot, as well as the actual message. Because querying, you don't require funds. It's just deps, which again is a reference to the storage object. The storage object is not an object. This is an OOP, but it's a trait. What is it? Yeah, it's a trait. It's an implementation of a underlying. My brain's gone blank. Struct. There we go. That contains a reference to the storage, and then you've got env and message, and again you'll see those roughly the same with instantiate, deps, and info, message. So we won't go too much into so other than say for both execute and query, what you're going to see is basically in every CosmWasm contract you look at, you'll see a match statement, and then you'll see the enum exhaustively match. That's basically the pattern, and then individual functions that actually work with that. And this almost everything is a response as results, and they return this response, which you can add attributes to, which are just extra data points that you will see reflected on chain, essentially. And this contract is too simple to have any examples of it, but you can also add additional events and sub messages. And that's where the actor model starts to come in, because you can do quite complicated behavior where contracts are sending sub messages to one another, or they're doing native actions on chain, like interacting with the bank module, or, well, there's a number of different things you can do, from staking changes to bank changes to whatever you like. And some of that will result in interacting with other entry points. So the 3 entry points we've seen here are instantiation, execution, and querying. There's also a reply, which is the main other entry point that you might see, and that's essentially the entry point for a contract receiving messages and then taking some action. So let's just have a little quick look at the instantiation function, and we can see this kind of ties together a lot of things we've been talking about in terms of like reading and writing and whatnot. So there's the message that comes in. So this instantiate message has a count with it. It has an owner, which is coming off the message info. So the message info is basically sent through from the underlying library. You can't change it. So when we see info sender, we know that is the signing user. This is really important because it means that you can, since all of these, every one of these function bodies will be atomic. So although when you write Rust unit tests, you obviously have to check that. So you might sometimes get false negatives or false positives when you write unit tests, right? Because this is just Rust code. When I run these unit tests, I'm just running Rust unit tests. So if I changed state on line 21, and then there was an error on line 28, the state would be modified, and the Rust unit test would go, whoa, something bad has happened. But when this actually runs in the wild, that wouldn't happen. That error would actually not change state because it happens atomically. So you quite often end up doing, if not quite short circuit logic, but like validation logic that just crashes out using the sender in particular, because authorization is usually pretty straightforward, just in the case of saying, is the sender the right sender versus who I'm expecting the sender to be, and then crashing out. And there's some additional hooks and tooling within CosmWasm standard to help you with those sorts of operations. So anyway, yeah, we're creating this state struct here, setting contract version. This is really, really important because otherwise you can't migrate the contract later, which is to say change the code, the contract code. And then state's getting saved, and then we're just returning a response with some attributes. So that's about it. That's a really quick, I appreciate I'm probably been talking quite quickly. So that's a pretty quick whistle-stop tour of how one individual entry point works. And if you want to see this this template, you can get it from the Wasm repo, just run it in your own terminal, and then you can sort of see quite easily how it, like, the flow goes through from this execute function to increment, to try increment down here. And then again, you're getting a state update, which is this kind of essentially like it takes an anonymous function and returns a result, and then as long as you return OK out of it, it will actually commit that state update. And you'll see, again, all these sorts of patterns, like as soon as you start looking at any non-trivial contract, they're all going to use a lot of the same sort of patterns, because it's all relatively straightforward. And the only bit of misdirection you'll see is on some contracts that are expected to be very, very commonly sort of imported to other contracts. Sometimes people wrap the entire thing in a massive sort of struct, and then sort of almost instantiate it as a trait that has some internal state of its own, so they can interact with it by simply instantiating it once when they're sort of referring to it in a contract that's got more custom code. An example of that would be the CWNFT's code. Whether or not that's the correct approach in the longer term in terms of maintainability, I don't know. There is actually still a lot of discussion about the design of a lot of this stuff. If it's something you're interested in, again, check out the code, see if you have any opinions on it. I think that's all I'm going to say about the code. So that leaves me to tab back to Chrome. No, it doesn't. Where is Chrome? That's not Chrome. There is Chrome. And oh, okay. That's not right either. Okay, so live demo done. So that's it. This is a thing you can see in the wild, which is working right now. I had originally thought I would show it, and then I've just realized that I can't even actually copy and paste it from this slide because I'm just viewing it. But it's an example of a live dApp working on a Cosmos ecosystem chain written in Rust. And that's it. That's the end of the talk. I had envisaged having some time for Q&A, and there is some time now. So if people have questions, then we can totally do that.
Let me pull everyone back in. We'll try and filter through if there's any questions on YouTube. And if people can also post questions, that'd be good, because there are not any questions yet. Right, hang on. There we go. That's Andy back. I'll get the ball rolling with a question. So you mentioned some stuff about unit testing these things. Now, obviously, that's pretty bloody important for these contracts, right? Because Yeah, get them wrong would be very bad, as a bunch of the Ethereum folks are finding at the moment, right? How sort of sophisticated is like the unit testing around this, like, and what's the sort of approach to that stuff?
So the answer is actually, I think you would be surprised how sophisticated it is. I mean, first of all, it's just Rust unit tests. So you can be as sophisticated or otherwise as you want, and the it's not part of CosmWasm core exactly, but there is a library called multi-test, which essentially allows you to fully mock a running Cosmos chain. So you can arbitrarily move blocks forward, move them back, and simulate the behavior of a chain. So the largest suites of contracts that are out there in the wild that have been written are, we're talking like 10, 15, 20 or more contracts that are doing a lot of native level behavior. And obviously implicitly, to be fair, actually the thing that people are most worried about, because it's quite blasé to like shuffle around tokens, that's just like everything does that all the time for whatever reason, right? And it's so well tested at SDK level that it's just a given that it will work, and people just trust that. But like things like messing around with governance, which again is more of a Gen 3 chain thing where you have people voting, and then so like a reason this is bad is if you're not familiar with Cosmos chains, you do software upgrades to the core chain via governance. You say, at this block we are going to change the chain's behavior, and the chain halts, and then all of the operators have to switch their binary. So you can see it's very, very, very easy to make very, very bad things happen if you start to mess around with governance. And one of the things that people are doing at the moment is starting to extend core chain governance functionality using smart contracts, so they can upgrade governance, because obviously what we've learned finally, essentially, okay, this is a bit mean of me, but I'm going to say it anyway, finally some nerds are working out that maybe the people who did political science at university might actually have something to contribute to governance, and maybe just having really, really simple solutions to a quite complicated problem, is not great. And so the thinking in the space is getting much more sophisticated. So governance is an example of a thing where it really has to be so governance is an example of something where the price of failure is really high for the chain, potentially, because the chain could just be bricked. And so there are not only quite complicated test suites now, which are dealing with a lot of contracts interacting, but they're dealing with things like governance as well. And they're using multi-test basically to ensure that behavior works. So that's really, really good. But even if you don't want to use things like multi-test where you're mocking an entire chain and able to, in a unit test scenario, have multiple contracts hitting each other, you can get a long way by just inspecting that response, because all of the data it's going to send fundamentally you can inspect, and you'll just see that in all of your, because it's an actor model, at the end of this atomic action, you can just look at the end and say, what is the message it's going to pass at the end? And you just see an encoded Cosmos message, and that's quite a bit of JSON. But if you want to, you can go all the way as far as like going like, oh, does it have this key? Does it have, I mean, in reality, it will be typed. So you can trust Rust to say, this thing is type Cosmos message bank message send v1. And you're like, I'm pretty sure that's a v1 API bank message send. But different people have different levels of paranoia about the level they want to unit test. And I think a lot of the larger projects are using multi-test.
Mm-hmm. Cool. Have we got any other questions? There's one which came on the YouTube chat, which is, what are some of the future plans for CosmWasm, which you may not know the answer to, but it's at least worth asking.
So I do know a little bit about the future plans for CosmWasm. Although obviously I don't work for Confio, who built and maintain CosmWasm, I do have some involvement with Wasm, who sort of do it, like I said, do a lot of the DevRel in the space, and a lot of the future development of CosmWasm, to be honest, the biggest thing at the moment is getting developers into the space. Like that is the single biggest thing, is like developer docs, tutorials, videos, outreach, trying to teach people why Rust is cool and they might want to write it over Solidity. I mean, that sounds insane. Like, given to me, Rust is so obviously superior to Solidity, and CosmWasm plus all its hooks are so obviously superior to Solidity. It just seems like a non-argument to me, but it is a thing. There are lots and lots of people who are very, very familiar with Solidity and don't want to give it up. So that's another thing. But also just generally, there's a lot of effort going into additional features into things like Storage Plus, which is the kind of database interaction layer, and also just the other biggest thing is that people are trying to build very, very large systems in it now, because it's so much quicker to iterate on using smart contracts on top of a chain than it is to build all of your chain code up from scratch, where you're having to upgrade the binary and run loads of test nets and check everything really meticulously. So what you're increasingly seeing in the Cosmos space is people who are launching a chain with CosmWasm rather than writing native Go code against the Cosmos SDK, which would have traditionally been how you would customize the behavior. They're instead just launching a CosmWasm chain and then building quite sophisticated native level code using CosmWasm. And one of the big things that's coming along that's interesting from that perspective is Confio, the people that make CosmWasm, are launching their own chain, which is basically for regulated scenarios for like banks to use and whatnot, called T-Grade. And as part of that, they have a way of essentially running these sort of like these pseudo, like super user contracts that can do more serious native level stuff with additional permissions around it. And there's a lot of very interesting stuff around that, basically. And so that, I think for the core CosmWasm folks, that's like one of their biggest focuses is getting T-Grade off the ground, and how that model might influence how people build large systems using smart contracts, using CosmWasm smart contracts.
Yep, absolutely. There are no more. I'll pull the slides up. There's no more questions right now on YouTube. If anyone's got any other questions, chuck them in now. Otherwise, we'll wrap up in a second. You guys think of anything, Andy, Jamie? Any questions? I'll throw one more at you. What's CosmWasm's weakest point? What would you say? Where does it need? I mean, you mentioned docs and stuff, but like, yeah, where does it need to get better?
Well, I mean, it would be really nice if Rust had like a merge function like Lisp does. Like I know this is such a dynamic language weenies complaint. Honestly, the weakest point of CosmWasm, I think, comes back down to the way Rust treats enums. You get like the fact that you kind of, the pattern is to use match statements and everything gives you like a quite a high level of confidence, and that all that kind of stuff is really cool. But the way that I think data structures are treated, or they're not data structures exactly in Rust, are they? They're kind of more data types, but the way they kind of work is, I guess, it's more of a Rust thing, like I say, than a CosmWasm thing. But it means you do, especially if you're extending behavior from like a standard or a spec. So like NFTs, where it's CosmWasm 721, which mirrors the Ethereum spec, which is whatever it is, ERC 721, or CosmWasm 20, which mirrors ERC 20 for tokens. So fungible tokens, CW20, non-fungible tokens, CW721. Both of those are specs that you extend generally. You don't re-implement them. But it ends up being, one of two problems happens, is that you end up either pastoring a lot of code, or you end up with quite a lot of, it ends up being quite verbose, even though a lot of it is literally data type definitions. I keep reverting back to Lisp terminology. And then the way around that is, I think I mentioned when I was showing the code, that some people have got around this by essentially doing much more, like wrap the entire interface for the spec in one massive struct and then just instantiate a version of it to say like, okay, now I can just access all of the functions that are associated with this spec. But it's really impenetrable to actually extend any of the individual behavior of that again. So you end up, and so you quite often end up seeing contracts with things like they've overridden part of an execute method and they've called it execute or execute burn or execute where they're, because there's somewhere a function called burn in the underlying trait, and that was the way they thought of to namespace it. So you end up with a little bit of verbosity and sometimes some weirdness when extending things. I think that's its weakest point, but then that's also because I think you could fit the number of CosmWasm developers on the planet into like a Virgin Pendolino, if not a London Routemaster bus, So the more people I think that work with the stuff in the wild and see those frustrations and then start to have opinions about the design of things that can be well extended, I think it will get better. My other big frustration, actually, while I'm thinking about it, is that obviously results are monads, basically,
Yep.
And I'm used to using both in, so I did a lot of monadic Clojure, which is obviously very unusually strongly typed Clojure. But you have manifold and a lot of those other libraries have like mlet and alet, which is essentially like a do in Haskell, but it's in the same form as like a let in Clojure. So you say like let bind this to this to this to this to this, and as long as everything on the right is a monad, everything executes, and then you just in your let statement you return the return, which is like a monad, right? And it's just really elegant, and it kind of fits into Lisp, into kind of Clojure like threading macro paradigm, right? And when I'm writing TypeScript, I really, really like working with that model as well, like almost like railway style programming, where you have like a set of ethers, and everything either short circuits or it completes, and so like the Haskell kind of do style notation, like pushed into a kind of railway format, I think is incredibly powerful. I really like it. And I think that's, again, maybe more of a Rust thing than a CosmWasm thing. I mean, though I guess you could write some hooks and macros in CosmWasm to help with that. But because everything is atomic within the context of one handler, I think it would actually be a really good pattern to use, because then it would also make unit testing, when you're unit testing in Rust, behave a little bit more like it will in the wild, like I said, where you can get something to fail the unit test in Rust, but actually if it was on chain, it wouldn't fail because the transaction is atomic. So if you encourage people to instead do something more railway style, where it's basically a chain of ethers, which is basically what a result is anyway, I think that would be a nice pattern. But obviously, I've obviously looked into this from a Rust perspective. I know it's a little bit non-trivial and potentially spicy. So yeah. I don't know if that's a good opinion or a bad opinion. Maybe it's a bad opinion for me to have.
It's a very functional programming meetup thing to go. The answer to your problems is to just put monads in. So,
but there already are monads. They're already there. We're just not using them well enough.
Exactly. Need more monads, more stuff. Right, there's one more question from YouTube, and I think after that we'll wrap up. But it's actually quite a good one. Coming from a Lisp background, are CosmWasm looking into formal verification of smart contracts? That's quite an interesting question.
Welcome to the can of worms. Okay. So at the moment, the how do I know what this is going to do question comes up a lot. It's a corollary, actually, of I think I touched on, where things that were custom are suddenly like no longer exciting. Like we saw on a smart contract chain, people going from day one smart contracts landed, they were like, oh my God, where are my airdrops? I want tokens. And then like day 5, people were getting airdrop tokens and they were like, it's a scam. Admins, devs, how do we not get airdrop tokens anymore? I don't want them. So, I don't think you could ever get like a product evolution curve happening that quickly anywhere else. But so people obviously are very, very interested in not only the verification of what something can do, but also, more broadly speaking, formal verification. I don't know is the honest answer to formal verification from a kind of like, Haskell Copilot, or what's the NASA one? Is it Copilot I'm thinking of? The library for doing formal verification. But also just more generally actually verifying what a contract is going to do. I anticipate that's going to change pretty rapidly. There's a group who just got funded by Wasm to do a bunch more stuff on security and what's it called? Like fuzzing and all sorts of proof of concept attacks and whatnot. Because again, there are almost so few people that understand this that by definition nobody's attacking it yet, because nobody understands it enough to attack it. So there's two parts to this. There's like the code side, which is the bit that us nerds care about, which is like formal verification, and then there's like the end user stuff, which is like, this is bytecode. Well, there's a WebAssembly code. How can I be sure that this is definitely the thing over here that's in this GitHub repo as an end user? Obviously, you and I can work out how to build it, check it, do they match? Robert's your father's brother. But your average user can't do that. And in addition, you're increasingly now sometimes having people a bit more coy about sharing their code, because, as I mentioned, everybody historically shared their code so they could go, we're open, we're secure, find our problems. We can show you we're secure because we've shared our code. And then what happens is everybody rips off your code. So now people who have like a thing they think is intrinsically valuable, and they think they are themselves trustworthy enough that they can get people to go along with them, are sometimes now not sharing their code. And that then, it's almost like breaking a social contract within space to not share your code. And then it's like, okay, well, can we definitely trust this? Because, sure, we know you guys, you hang out in Discord, but do we really know you? Have we ever met you face to face? And doubly so if you're an end user, right, who's trusting your tokens or NFTs or whatever. Sorry, that probably didn't actually answer the exact question. But
I mean, so many of these things, really, the answer is whatever's happening soon in Rust is the thing that's happening in CosmWasm, right? So yeah.
I mean, when you're developing it on your computer, you are just developing Rust. Oh, actually, no. Another point, you asked about weaknesses. Another weakness is that the Wasm VM doesn't work yet on ARM. So you can't run it on a Raspberry Pi, you can't run it on an M1 MacBook. So you can develop the Rust part, you just run the Rust unit test and stuff, but you can't like run it against you can't just like spin up a chain on your laptop and throw it at the chain unless you do the whole thing in Docker, which is a bit of a pain. But I don't have an M1 MacBook, so that's why I had forgotten about it until
now. Cool. Right, I think we should finish up at this stage because we are near the hour mark, so that's all good stuff. Yeah, cool. So pre us talk before we were on the stream, we were talking about given that it's two meetups that are both Manchester based, likely we'd quite like to do something in person soon. So I was just generally going to throw out the idea, that maybe in April we'd like to do something IRL effectively. So I suppose really this is a question mark, and if people want to do that, or if people really, really don't want to do that, if you could let us know, that would be good. I don't think there's anything else to add on that, is it? Just that we appreciate that, the real world is beckoning, basically.
Yep. And if there's actually on that note, I also said if there's anybody that's interested in maybe doing this as a workshop, this stuff is a lot easier to explain when you're in a room with people. And most of this Gen 3 chain stuff, you can literally just run the dev chain on your laptop and then throw smart contracts at it and then develop in a browser on a machine. That's how I build. And especially with the chains that I've been helping out with, we've done a lot for developer documentation to the extent that you can have a one-line command to spin up a blockchain with smart contracts on your laptop, and then you can write Rust against it. So that's an option for a future meetup if you want a spicy thing. And final thing, although I don't work for a company anymore, so I can't go, and we're hiring, but we would like more devs to write smart contracts in Rust. And there's absolutely tons of developer grants and hackathons with money attached in the space, and too many for me to iterate now. So if you're interested in doing this, and making money from it, and maybe doing cool stuff, Lambda Lounge Discord, come say hey, and say what you're interested in. I can point you in the direction of grants and bounties and learning documentation and help, and I'm happy to answer questions and show you code and stuff too, because although I may not be a crypto true believer, I really like Rust, and I think smart contracts are only starting to do cool stuff. So I think it would be cool if more people did things that weren't just fucking meme coins. So please come and help not build meme coins, build interesting technology.
Yep. Cool. So I've just posted the Discord link. I'm going to throw a Zoom link now for anyone who fancies, anyone who fancies chatting for a little bit after. Thank you very much, Alex. I appreciate it. I put on you and said, come and do both of my meetups for me, please. And you've delivered on that. So thanks. That's really good. But yeah, hold on. I'm just going to send a Zoom link now because I have to both generate a Zoom link and then put it in the chat. So here we go. Yeah, apologies. Don't crash on me now, computer. Now is not the time. Right, here we go. So there should just be a Zoom link on the way in the YouTube chat. If anyone wants to join us, please do. But yeah, other than that, I'm going to end the broadcast and thank you very much. Cheers.